In this video, we will see if a number of dielectric slabs are present between the two charges, then what is the force between the two charges. Let us say we have two charges Q1 and Q2. Both of them are separated by a distance d, and between these two a number of dielectric slabs are inserted. K1, K2, K3, Kn are dielectric constants. T1, T2, T3, Tn are the thicknesses. Then from the previous equation we can get force between the charges F is equal to 1 by 4 pi epsilon naught Q1 Q2 whole divided by d plus T1 into root K1 minus 1 plus T2 into root K2 minus 1 and so on, plus Tn into root Kn minus 1 whole square. If only one slab is there, we will take only one term. If two slabs are there, we will take two terms. If n slabs are there, we will take n terms. Right? Then, if the entire gap is filled with the dielectric slabs, that means the distance between the two charges d will be equal to T1 plus T2 plus T3 up to so on Tn. Use the above equation. And the above equation we have d plus T1 root K1 minus 1. So if you simplify here I will get minus T1, T2 root K2, T2 root K2 minus T2, Tn root Kn minus Tn. But d is equal to T1 plus T2 plus T3 up to so on Tn. So d will cancel with T1, T2 and Tn. And we are left with T1 root K1 plus T2 root K2 plus Tn root Kn whole square. So the force between them F is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by this term. So what are the different formulae we need to remember for solving various numericals on Coulomb's law? First one, force between the charges in air or vacuum F0 1 is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R0 square. Force between the two charges in medium Fm is equal to 1 by 4 pi epsilon Q1 Q2 divided by Rm square. 1 by 4 pi epsilon naught value 9 into 10 to the power of 9 Newton meter square per Coulomb square. Epsilon naught value. And Coulomb's law in vector form F bar is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square into R cap. R cap can be written as R bar by R. So R square into R is R cube. Force acting on first charge by second charge is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R12 cube into R12 bar. Force acting on second charge by the first charge is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R21 cube into R21 bar. And as we have seen in the previous videos, F12 and F21, they form action and reaction pair. Action and reaction, both of them are having same magnitude but opposite in direction. And then dielectric constant of the medium or relative permittivity of the medium is equal to epsilon by epsilon naught, that is also equal to F0 divided by Fm. As you know very well, epsilon naught permittivity of free space or vacuum, epsilon permittivity of medium, epsilon r relative permittivity, K dielectric constant. Epsilon r no units, K no units. And it was observed that for air or vacuum K value is 1. For metals K value is infinity. For dielectrics K value lies between 0 and infinity. And next one, If two charges experience same force in air or vacuum and in medium, then their distances are related as R naught is equal to root k into R. When a partial dielectric medium is present, then the effective distance felt by the charges d air is equal to d plus t into root k minus 1. When a partial dielectric slab is present, then the force experienced by the charges is equal to 1 by 4 pi epsilon naught q1 q2 divided by d plus t into root k minus 1 whole square. When the entire distance between the charges is filled with a dielectric medium, then the force between the charges F is equal to 1 by 4 pi k epsilon naught into q1 q2 divided by d square. When a number of slabs having different dielectric constants and different thicknesses, then the force between the charges F is equal to 1 by 4 pi epsilon naught q1 q2 divided by d1 d plus t1 into root k1 minus 1 up to so on tn into root kn minus 1 whole square.